Everyone, Michael Turner with Classic Urban Homes, and we're back here in Midway Hollow on our ICF project with Alan Hoffman. And in this video, what we want to talk about is a little bit about how these blocks are put together. So, Alan, I see you've laid out a few blocks for us here, and this is really cool right here. We've got these cool corner blocks right here that have this nice kind of rounded radius to it. And as we all know, concrete doesn't like sharp angles.
It does not.
Concrete prefers radiuses, less cracking when you have radiuses in concrete, and so I'm assuming that's probably helping with that kind of idea.
It helps the flow, and when we pour these walls, which when we do the pour, I'll show you with the concrete. You start in a corner, we bring it up in about 4-foot lifts, and then it starts flowing diagonally through the whole wall.
Gotcha. Yeah.
And then we also we vibrate it with a 1-inch vibrator, and then we also pound on the wall, especially around doors and windows, because that's where you want to get your best control.
Try to eliminate any kind of honeycombing or anything like that you've got in those areas there. So
this is pretty simple stuff in terms of putting together. So as you can see, the tongues, we talked about this before, but everything kind of fits together, and you just pound it in place, and that's it. Move on down the wall.
And these are cool because what you've just done is you've crossed these sections. This one here, like you said, they're reversible, interchangeable right here, where you've got 1 foot and 2 foot, and you flip it over, so everything's kind of locked together. So we've bridged the two blocks, and then the next section right here is. I know I'm not a certified installer, but I'm going to go ahead and
we're going to get you there.
I'm going to go ahead and just show how easy this is to do here.
Okay, you're hired.
Looky there, folks. I did it.
And then, I don't know if we've got those clips around, but basically the one we used over there.
Yeah, and that's where you'd lock the clips in between these adjoining pieces, both vertically and horizontally.
Yes.
Yeah.
Yep. And that keeps the block from lifting.
Right.
And it holds everything together, so we get a solid. We used to use adhesive, that foam adhesive, to glue everything together.
Right.
But this is so much better.
Yeah, that's impressive stuff. And then let's see here. Let's see if we can find a section to show, because obviously all your wall sizes are not going to be completely modular, right? It's not all. You're going to have areas where I've noticed on this one right here to where, we're kind of an odd dimension from the block. And I've noticed where Jerry will start kind of at the outside corners to where everything's kind of locked in.
And we'll do that.
Work towards a wall. Yeah, okay.
Wherever we got a window or door, that's where we'll meet the block.
Right.
And I don't know, we're on cable TV here, but that's called a bastard block.
Okay. All right. Gotcha. Yeah. And I've noticed that is like when you cut that, and it's not a factory cut, that he'll use that same adhesive foam that he's got on the base to kind of fill that void, connect them, and then obviously when you think of it as in the form standpoint, it's so concrete can't come out of that area right there, because as we know, once that stuff dries, it's a little difficult to kind of scrape off the
we like to get it right the first time.
Yes.
It makes it so much easier.
Right. Yeah. Absolutely.
Especially where you're placing windows and doors, you want to make sure it's not easy to cut out a header.
Yeah. No doubt. And that's a very good segue into doorways and window openings. So what we have right over here, nice big window opening here in the master bedroom. We've got a door right over here as well. And obviously in traditional wood construction, we're used to attaching our windows to a wood frame. We'll nail or screw those into a wood frame. And I noticed that we've got these, I believe they're called bucks, right? You've got these window and door bucks, and that is a treated 2x12, which it matches the same thickness of the ICF blocks.
Correct.
And so that's a great filler around those. Gives you something that obviously we can nail, sheetrock right to on those edges. We can fasten the windows to it and flash them and everything like that.
Standard windows, standard doors.
Yeah, from the outside. And obviously on these header pieces right here, you want a solid piece up there, don't you, Alan? I mean, it would be bad if it was open up there, wouldn't it?
Yeah. So our headers, we've got to pay attention to how much concrete we have above a rough opening. And so when we're involved in, like for instance, on the other side of the house, you've got a window that's got 4 feet of concrete, we don't have to worry at all about it.
Gotcha.
But when we've got about 16 inches or 15 inches of concrete, we do have to put a lot more heavy steel in there. We put, especially if it's a long span, over 3 feet, we put what's called a saddle.
Okay.
And we put them in on every 8 inches. So we have these saddles, which basically, concrete does 2 things. It turns gray and it cracks.
Yes, yes.
Okay. So the saddles are direct to cracking.
Okay.
So that you know what a keystone is.
Right.
So it creates basically a keystone.
Perfect.
So the saddle does that.
Okay. All right.
So ultimately, holding these bucks in, and we don't see it here yet because we're early in the process, but right when we're ready to pour, we have these 6 and 7 inch long galvanized lag bolts that we drill holes in here that we'll put 3 from top to bottom in here, and that holds the bucket from below. Right,
because this stays in place. This doesn't, it's not like just a form that you're going to pull off later. We want that there, so we've got something to wrap drywall, wood window jams, whatever you're doing with. You want something that you can attach to. And I noticed that here on our window seal that we're using 2x4s, we're leaving that open, and obviously that facilitates being able to pour concrete down into that void.
And then we'll trowel the concrete right flush with the top of this wood.
Gotcha.
So that's really when when the homeowners come in and see it after the pouring and say, yeah, we did put the concrete in the wall.
Yes, exactly.
It's definitely there. But it sounds very different when you pound it after the concrete.
Well, and I've walked a couple of your homes over there in East Dallas, and that's where if you need an ICF home in East Dallas, this is your guy to talk to. If you need one on the west side of town, we're hopefully going to work a deal out here to where I'll become we'll
get you
a certified builder for Mr. Hoffman here, and but it's just looking at this in the thickness of these window jams here, these window bucks, man, that's massive. That wall has got some beef to it.
It's really strong, and I know that through this area, through this neighborhood, you had some serious tornadoes a couple years back.
Right.
And these walls are over 200-mile-an-hour wind walls.
Wow. So
it's a meaningful safety elevation of the build, and then quantitatively on the energy consumption side, they're gonna see serious benefit. Right. It's very comfortable.
Well, I noticed when we were doing the load calcs on the air conditioning, it's really, what do you say, probably about 50%, use about 50% less air conditioning than what you would need in a traditional wood frame home?
Yeah, as good as the new equipment's gotten, if you want to be at 60%, that's fine, because you can dial it down with a variable speed unit. But at the end of the day, it's in the 50% range. And that's hard a lot of times for the AC contractors to, actually their scales don't really go, I think, below or go above R37.
Right.
So it's hard for them to really firmly say, hey, this is going to get there.
Yeah.
And we do have scientific testing. There's a firm out of Chicago that talks about that low mass wall versus this.
Yeah. Well, and that's an important topic that you bring up is the massing of the wall, and kind of the whether it's a heat sink, that thickness of concrete and the way it absorbs either the hot or the cold, and it really holds that, and the sound. The way it just kind of holds that temperature for a much longer period than a traditional wood frame wall. So about impressive stuff.
Typical 2x4 frame wall with bats insulation. If your temperature's rising, the heat buildup starts 6 in the morning in the hot summer months, and by 10 o'clock in the morning for most homes, their insulation is done. Because at that point in time, you're getting thermal conduction through that wall.
Right.
You're getting radiant heat. And the reason you got to run an air conditioning unit 24/7 many times in a Texas summer is that in order to feel cool, because you've got all this radiant heat coming through the walls, you've got to move the air.
Right.
And so just to feel comfortable. Now, many times when someone moves into one of these homes, they're going to find they're going to set the thermostat at a higher number, because they don't necessarily need to have it be that cool.
Right. Well, and use what I'll tell a lot of our clients is you know, it's important to maintain a good humidity level. You know, a lower humidity level, you know, around 45 to 50%. Is that typically kind of what you're?
55.
Okay, 55. Yeah. You know, because you'll feel cooler.
Yes.
You know, at a lower temperature than, you know, you take a traditional built house and a single stage air conditioning equipment, and that AC kicks on. You know, it cools that house down to you know 70 degrees or 65 degrees, and it kicks off really quickly.
Yeah.
And what it's done is it's really dumped a lot of humidity in the air.
Yes.
And you know you're chasing comfort at that point as opposed to, you know, temperature. You keep wanting to lower the thermostat because you feel sticky in wet. And I know in just an airtight house period, and even more so in this one, you'll be able to set the thermostat at a higher level and feel more comfortable.
Yeah. And we do encourage everybody to use the ventilation fans in the bathrooms, because, you know, one of the things is when you're talking about this being so well insulated and tight, and the fact that we're doing the full foam encapsulation on the attic area, you look at really trapping humidity in. So if you take a long shower, you're introducing a ton of humidity. So you've got to manage that humidity in this house. You have to be cognizant of it during in the design of the system and make sure that it's dealt with.
Yeah. And I know that's what I've kind of talked. You know, you and I have had several discussions on it, and that's something I've always tried to make sure that we're doing is trying to make sure that we're getting the humidity out of the house. You know, using, you know, variable speed, multi-stage, you know, air conditioning that is helping to dehumidify.
And
you know,
whole house dehumidification too.
Whole house dehumidification. Also using, you know, bath fans. You know, because sometimes people just forget to turn the bath fan on when they get in the shower, right? And you know, we've got smart bath fans now that will sense the humidity for you and turn themselves on and help pull that wet, humid air out of here. So there's a lot more that goes into it than just putting a
science.
Yeah, there's science to it. Yeah, absolutely.
And so the main thing is coming away with these walls. When I speak to people and the customers over the years, is it's just a high level of comfort you experience,
right?
And security from the safety. But I look at the safety is paid for by the energy savings.
Right. Yeah.
It's a little bit more.
Yeah.
But you know, if you really look at the long-term costs and how long this house will be here,
right? Yeah,
it pencils out.
Yeah, absolutely. You know, and then, you know, like we were talking a little bit about the assembly, and part of that is what you want to make sure you're doing is you've got this great wall mass, you've got this great insulation system going on right here, and you want to carry that through that entire envelope. You know, so you want a really good energy efficient window in that. You know, we're using the Anderson 100 series on this right here with their proprietary Fibrex material.
It's fantastic.
That it's they've got good R ratings on those. The you know, with that frame, it's kind of like a composite fiberglass type material.
No heat transfer.
No heat transfer on that, which is really important on that. So, you know, when you do this, folks, you really got to think about the entire system that goes in here, because you know, you're starting off with a super high performance wall, and you want to make sure that all those openings, all those penetrations are just as high performance. Because it doesn't do you any good to put a Ferrari engine in a Pinto, right? We want
or Pinto tires on a Ferrari.
There we go. So we want the full Ferrari experience here. So
I love car analogies because they apply.
Right. So fantastic. Well, Alan, we appreciate your insight on this, and thanks for explaining what we got on.
I appreciate working with this customer and making it happen.
Well, we're super excited for it, and can't wait to see you guys on Port Day. Thank you.